All right, today we are going to crack open your computer, your phone, maybe even the internet itself, to really demystify one of the most fundamental ideas in tech, storage. We're going to break down the big differences between RAM, hard drives, and the cloud, and we're going to do it in a way that just makes sense. So let's dive right in. It seems so simple, doesn't it? You just click a button and poof, your work is safe forever. But where does it actually go? And why is it that some computers feel like they're flying while others just chug along? Well, the answer to all of that is in understanding where your data lives, both in the moment and for the long haul. So to make this all super easy to grasp, we're going to use one simple analogy for this whole explainer. I want you to think of your computer not as one big single machine, but as having two different kinds of brains. Yeah, kind of like we do. One brain for active thinking and another one for remembering. And this idea maps perfectly to how your computer operates. It's got a short-term memory that's constantly juggling everything you're doing right now, all your open tabs, the apps you're running. It's incredibly fast, but it's also temporary. And then it has its long-term memory. Think of this like a giant, permanent library for every single thing you've ever saved. It's a little slower to get things out of, but it's built to last. Okay, so let's start with that first brain, the fast, active, short-term memory. In the computer world, this is what we call RAM, and you can think of it as your system's temporary workspace. The official term for this kind of memory is volatile storage. And honestly, volatile is the perfect word for it. Just think about any time you've worked on a document and forgot to save. If the power suddenly goes out, poof, it's just gone. That's because it was living in this volatile, temporary space, just waiting for you to tell it where to go permanently. And that right there is the whole job of RAM, which stands for random access memory. Its amazing speed is what lets you have, 20 browser tabs open while you're also streaming music and editing a photo. So the more RAM you have, and it's usually measured in gigabytes, the more things your computer can actively think about at the exact same time without getting totally overwhelmed. But of course, once you're done working on something, you need a safe place to file that information away. So now let's move to our second brain, the computer's long-term memory. This is its permanent filing cabinet. And this is what we call non-volatile storage. Now, unlike its volatile cousin RAM, this type of memory holds on tight to your data whether the computer is on or off. That moment when you click save, what you're really doing is telling the computer, hey, take this information from the temporary workspace of RAM and move it into this permanent filing cabinet for me. And that filing cabinet can come in a lot of different shapes and sizes. The most common ones you'll find inside your computer today are hard disk drives, or HDDs, and solid-state drives, or SSDs. But this also includes things like those little USB flash drives you carry around, and even older formats you might remember, like CDs and DVDs. They all share one critical feature. They don't forget when the power goes out. Okay, so for the main storage that's actually inside most computers, it really comes down to a big showdown between two technologies. So let's put the two heavyweights, HDDs and SSDs, head-to-head and see how they stack up. This really breaks it down perfectly. A traditional hard drive, an HDD, it literally works by moving a tiny physical head over magnetic spinning disks to find your data. Kind of like a record player. This makes them a bit slow, but they are fantastic for storing huge amounts of data without breaking the bank. On the other side, you've got a solid-state drive, or SSD. It has absolutely no moving parts. Instead, it uses flash memory chips, which means getting to your data is almost instant. And that's the secret to its rocket-like speed and durability. And it's why a computer with an SSD can boot up in just a few seconds. Now, if a standard SSD is like a sports car, then NVMe is a Formula One racer. NVMe is basically a way for an SSD to talk directly to your computer's brain, its main processor, cutting out all the slow middlemen. The result? Just mind-bendingly fast performance. This is the stuff that's crucial for serious pros doing video editing or for high-end gaming. So far, we've pretty much been talking about the storage that lives inside a single machine. But what happens when you need to share files with other people or get to them from anywhere? Well, that's where we zoom out from the personal computer and move into the world of networks. First up is something called Network Attached Storage, or a NAS for short. The absolute easiest way to think about a NAS is like having your own private personal cloud. It's a little box with hard drives inside that sits in your house or office connected to your network, giving everyone a central spot to store and share all their files. But hold on, here's a really important question. What happens if one of the drives in that central storage hub suddenly fails? All your data could be gone just like that.
That is the exact problem that this clever technology called RAID was designed to solve. RAID uses multiple drives all working together as a team. It creates a powerful safety net by either mirroring your data or spreading it out intelligently across the drives. So if one drive does fail, the others have you covered, and all your precious files stay safe.
And then, of course, there's the cloud. You use it all the time. Anytime you use a service like Google Drive or iCloud or Dropbox, you're using cloud storage. It's really just space on these enormous, powerful computer servers owned by big companies. Space that you rent and access over the internet. And the killer feature here is, without a doubt, accessibility. You can get to your files from your phone, your laptop, any connected device from basically anywhere in the world.
Okay, wow, we've covered a lot of ground here, right? We've gone from temporary memory to permanent drives all the way to the internet cloud. So let's bring this all home and figure out what it all actually means for you. This really is the key question, isn't it? And the right answer depends completely on what you do. Are you a gamer, a video editor, a writer, or maybe you just browse the web? Each one of those has very different needs. So let's turn all this tech talk into a super simple buyer's guide. Look, if your computer feels sluggish and slow when you're trying to do a bunch of things at once, the problem is almost definitely your RAM. More RAM is what you need. If you want your whole system to just feel snappy from the second you turn it on to launching apps, an SSD is the single best upgrade you can make. If you just need a giant digital warehouse for things like movies or huge photo libraries, and you want the most space for your money, a classic HDD is still the king. And finally, for backups you don't have to think about and the freedom to get your files anywhere, the cloud is an absolutely essential tool. So the crucial point here is this. It's not about which type of storage is the best. It's about understanding the unique job that each one is designed to do. From the lightning-fast, temporary thoughts happening in RAM, to the permanent files living on your drive, all the way to the go-anywhere access of the cloud, they all have to work together to manage your digital life. And that just leaves us with one final thought to chew on. Every single day, we create more and more and more data. As our digital universe keeps expanding, what kind of new technologies will we have to invent just to store it all? I mean, what comes after the cloud? That's a story for another day. Thanks for joining us.